So the next example here is that of an insurance agent. So it says that an insurance agent has claimed that the average age of policy holders who insure through him is less than the average for all agents, which is 30.5 years. So what is this 30.5 years? So according to this is the average. For whom? For all the agents. So that means this would be the average for the population. So this would be the mu in this case. Now they are saying a random sample consisting of 100 policy holders. So here this is the sample whose members are 100 total. So here this represents the small n, right? The number of elements present in the sample. So they are saying a random sample of 100 policy holders who had insured through him gave the following age distribution. So this is the age interval: 16 to 20, 21 to 25, 26 to 30, 31 to 35, 36 to 40. So that is given to you, and the number of persons falling in this class intervals is also given to you. So this is the sample. So in this question they have not directly given you the mean and standard deviation. So first of all, using this data you have to calculate the mean and standard deviation, and then you would be able to test his claim. So here they are asking, calculate the arithmetic mean and standard deviation of this distribution, the first task, and then use these values to test his claims. So at 5% level of significance. So here they have also not directly given you the hypothesis. So let's proceed on to the solution. So the first task is to define the hypothesis. So here you should note that what thing do you want to test here? That is the thing. So what you wanted to test here, you wanted to test the claim made by the policy insurance agent. What did he claim? He claimed that the average age of policy holders who insured through him is less than the average agent. So he wanted to check that the average age of policy holder is less than 30.5 years. So this he wanted to check. So corresponding to this alternative hypothesis, we would have to construct a null hypothesis. So what would be the null hypothesis which is opposite to this? They are saying less than 30 years. So here we assume that it is equal to 30. So this would be your null hypothesis. Exactly equal to 30. So here, because this is once you may see this less than sign, so therefore from here you may directly write this to be the one tail test. And which tail it is? It is the left tail test. Right? So this much information we have. Next, we wanted to test this at 5% level of significance. So therefore, your level of significance is equal to 5%. Third thing, you wanted to calculate your test statistics, which is given by x bar minus mu divided by the sigma divided by summation square root n, right? So you have n with you, which is 100, the number of elements present in the sample. You have the value of mu, which is equal to 30.5. However, you do not yet know what is x bar and what is s, the standard deviation for the sample. But you know that sigma is equal to s here because the sample is large. So therefore, the first task in step 3 would be to calculate this x bar and s, the mean and the standard deviation. So here the sample data is given to you, this one. So according to that, how do you calculate the mean and standard deviation? So let me write down the data once more. So the age is given to be 16 to 20, then from 21 to 25, 26 to 30, 31 to 35, 36 to 40. So this is the class intervals. Then this is the frequency, the number of persons lying in the age group, that is 12, 22, 20, 30 and 16, right? So from this data we have to calculate our mean and standard deviation. So these are the two formulas for mean and standard deviation. Now here what is A? A is the assumed mean. D is the midpoint values, scaled midpoint values, right? I is the length of interval. And what is N? N is the total frequency. So when you add up all this 12, 22, so you will get 100 here, which is the sample size. So N here is 100. So let's calculate this D and A and I. So let's do that quickly. So for that, we firstly calculate the midpoint of these intervals. So the midpoint of 16 and 20 is 18. 21 and 25 is 23. Then we have 28, 33 and 38. How do you calculate that? 16 plus 20 divided by 2, which is 18. 21 plus 25 divided by 2, which is 23, and so on. So after calculating this midpoint, we calculate D. We firstly assume this to be the assumed mean. You could assume any value. So for convenience, we are assuming the middle value to be A. So what is D? D is this midpoint, which is M. So this is M minus the assumed mean divided by the length of the interval. What is the length of this interval? It is 20 minus 16, that is 5. So it is I, which is 5. So we have M minus 28 divided by 5. So we have to calculate this. So for the first entry, it is 18 minus 28 divided by 5, which is minus 2. 23 minus 28 divided by 5, which is minus 1. Then it is 0, 1 and 2. Next, after calculating D, we will calculate FD. That means the frequency multiplied by D and then FD square, right? So you can do that. You can multiply this with this. So you will have minus 24. Similarly, the whole column. So it would be minus 24, minus 22, 0, 30 and 32. And similarly, you will multiply this with the square of this. So it would be 48, 22, 0, 30 and 64. Then you add up all these. So you will have summation FD square. So it would be 164. Then you add up all this. So it would be summation FD, which would be equal to 16 here. So you have all the values. You can substitute in the mean. So it would be 28 plus 16 into 5 divided by 100, which when you calculate, this is equal to 28.8. So this is the mean value of what? Of years. So 28.8 years is the mean value of sample. So this is your X bar. Then you will calculate your standard deviation. So I value is 5 into square root of summation FD square. Summation FD square is this one, 164. So 164 divided by capital N, that is 100, minus summation FD. Summation FD is your this one, 16. So 16 by 100 whole square. So when you solve this thing, you will get the value as 6.35 years. You may check this calculation. So now you have this value. Now this is your sigma, and because we have large sample, so this is also equal to, basically this is your S, and because we have large sample, so this is equal to sigma here. So now we have all the values, so we may calculate the Z statistics. So Z calculated, that would be X bar minus mu divided by S divided by square root N. So this would be equal to 28.8 which we have just calculated minus the mean value which we wanted to test divided by this standard deviation. So this would be 6.35 divided by square root of n. So when you compute this, it will come out to be minus 2.681. So this is your calculated Z value. Now we require in the next step, we require the tabulated value. For the tabulated value, our test is one tail and we wanted to check it at 5% level of significance. So according to that, let's move on to the statement of the question. So here in the statement, they have given you the value 1.645. Because it is left tail test, so the value would be, so the Z tabulated value, it would be negative, on the negative side, so it would be minus 1.645. Otherwise, what you can do for one tail test for 5% level of significance, you may go back to your table, this one. So here for one tail test and for 5% level of significance, your value is this one. Because it is left tail test, so this is negative value. So minus 1.645. Okay. So for this value, we have this tabulated value. Now in the next step, what we do, we compare. So we draw the critical region for our question. So this is the distribution. Here in this distribution, our tabulated value is minus 1.645. So according to that, this is our critical region. So in this critical region, we will reject our null hypothesis. So now for comparison here, let's see our calculated value. Our calculated value is minus 2.681. So minus 2.681, which would lie where? Minus 2.681. So obviously it would lie somewhere here, minus 2.681, because this is greater than this thing, right? So according to this, because our Z calculated value, which is equal to minus 2.681, is less than the value minus 1.645, which is equal to the Z tabulated, right? Therefore, we will reject the null hypothesis. So accordingly, if you reject the null hypothesis, therefore you accept the alternative hypothesis. So what is the alternative hypothesis? Alternative hypothesis states that mu is less than 30.5 years. So that means the average, so let's go back to the statement of the question. So the claim made by the insurance agent, it says that the average age of policy holders who insure through him is less than average for all agents. All agents is the population, right? Average for all agents is the average of policy holders who insure through him is less than the average of all agents. So that means mu here is less than 30.5. So this alternative hypothesis is correct. The null hypothesis is incorrect here, because this is by virtue of the Z test that we have applied. So therefore, finally we will conclude So in the sixth step, we will conclude the result. So we will say that the result or the claim made by the insurance agent is correct with 5% level of significance. Now this thing is required because we are not 100% sure that the claim made by him is correct. There is still 5% chances that we may make an error in concluding this result. So this is all about Z test for single mean.